Okay, in reference to the last one, I can graph the equation they gave me on Desmos. I move the 1 over to the left side so it equals 0. And then the place that I'm interested in becomes the solution. And you can see how I get pi over 2. I have to modify the equation a little bit because Desmos doesn't like it, equal to 1. So finding the zeros of a rational function. Okay, so hopefully you recognize this top part as a to the third minus b to the third, where a is equal to x and b is equal to 2. And you would say, okay, a minus b is equal to, times a squared plus ab plus b squared. Hopefully you're remembering this. X minus 2 x squared plus 2x plus 4, 2 squared. And that is over our denominator, which we can't factor. We can't factor a lot here, but we can see that right there. And there's a 0 for us. So we're going to say x is equal to 2. That's a 0. And there's nothing else that makes that 0 on top. Hey, there's nothing that makes it 0 on the bottom either, so there's no asymptote. So let's see what we have here. Well, if we look over here at this nut, there is an oblique asymptote because the degree of the numerator is exactly 1 more than the degree of the denominator. So there is a slant asymptote. And we find the slant asymptote, if you recall, by dividing the denominator into the numerator. And we say, well, here it takes x times x squared, x to the third, and x times 4. Okay, so I have plus 4x. And I subtract, so I get negative 4x, and I have negative 8. And I can't make x squared plus 4 become negative 4x minus 8. So I just write that as a remainder. And if you recall, the remainder doesn't matter when it comes to an oblique asymptote, because as the bottom of my remainder gets, as x gets large, the bottom wins. It wins much more than the numerator. So since the bottom is growing so much faster than the numerator, it becomes really close to 0, and we really don't have to care about it. So the main thing that we're looking at is the x. Okay, so my oblique, or my slant asymptote, is y equals x, just x. And I can ignore the remainder safely, pretty safely. Okay, so we'll say, here's my little graph here. I have a 0 at 2, so there's a 0. I also have a slant asymptote at y equals x. And then I'd like to fill in a little information just to see how things are going. So let's see here. What can we say? Well, 0 is not too bad. When I put in 0 to the original equation, I get negative 8 over 4, which is negative 2. So when I'm at 0, I'm at negative 2. So we'll say that's negative 2 right there. This is positive 2. When I put in, I know what happens when I put in 2, I get 0, because that is a 0, and that is what I get. And let's see, how about when I put in 4? What happens when I put in 4? Well, let's see, 4 is, I get 4 to the third minus 8 over 4 squared plus 4. So that's what is that, 64 minus 8 over 16 plus 4. So we're talking 56 over 20. What is that about? It's almost 3. So we'll say almost 3 at 4. So here's 4, we'll say. And, you know, when x is 4, this line is 4. So I'm going to be a little less than the line, right? So we'll say right about there, something like that. Okay, let me go the other direction. Let me say, we'll say -2. What's happening when we're at -2? And let's see, -2 to the third power minus 8, and -2 squared plus 4. So we'll say, well, let's see, that's -8 and -8, and +4 and +4. So we get -16 over 8. That's a -2. So I get -2. So at -2, about right here, I guess, I get -2. What did I do wrong? What did I do wrong? Because it doesn't seem like I should. Oh, you know what? You are allowed to cross a slant asymptote. It's not like a vertical asymptote. You can actually cross it, and we're crossing it right there. We're crossing it right there. So if it's a horizontal asymptote or a slant asymptote, you can touch it. It's not the electric fence. You can touch it. So there we go. It happened to be right there at -2. And then I guess we'll say -4. So -4 to the third power minus 8. And we'll say -4 squared plus 4. And let's see, we'll say, what is that? That's a -64. Is that right? Yeah. Just like above, only now it's negative because it's to the third power. And we have 16 plus 4. So we get -72 over 20. And, you know, it's not 4. But it's pretty close to -4. So, you know, we're graphing. We're not trying too hard here. You know, within reason. So if that's -4, then we'll say we're there, but not quite, huh? Not quite. We're on this side of the line. We're not quite that negative. Okay, so I think we can about get what's going on. It's gonna poof out a little bit on the negative side here, but then it's going to adhere to the asymptote, and then it's going to go a little squirrely in here, but eventually it's going to come back to the asymptote. Okay, there might be a little more wiggle in there, but we're not being that careful. Okay, so there we go. That's how we do it. And when it's a slant asymptote, we probably have to plot a few more points like I did. Because who knows what's going on when it's going to cross. If it's going to cross, it's probably going to cross. So we're kind of curious. We have to plot a few more points to get a good picture. And there's no shame in that. Okay.